Dear students, welcome to the last class of our chapter 3 temperature part 2 soil temperatures. Now in this class we are going to discuss and learn basic soil temperature terminology, results of research on effect of temperature on important crops like rice, groundnut, sugarcane, cotton, and units of measurement. Finally, the growing degree day concept. Now, before I actually go into the class, would like to just tell you a small story. Once, on a winter day, a farmer found a snake stiff and frozen with cold. He showed lot of compassion on it. He took it with a lot of care because it was stiff and frozen, thinking that it won't do any harm to him. Placed in the backyard of his home. He slept. The snake was quickly revived by the warmth of the house in and nearby surroundings. Thereby, it resumed its natural instincts. What is natural instinct? Snake bites and kills. Okay? So, the snake quickly revived, resumed its natural instincts. Then what it did? It inflicted the farmer with a mortal wound and it bit. Crying, the farmer died. He breathed last. Just before he breathed last, he said to himself, I am rightly served for pitying, carrying a most dangerous, venomous, whatnot, a snake. What is the moral of the story? The greatest kindness will not bind and will not bind the ungrateful. Okay, the greatest kindness will not bind the ungrateful persons. Okay, good. Let's go into the class. Now, the first part of this class is the basic terminology. What is thermal conduction? What is thermal capacity or heat capacity, thermal diffusivity, specific heat, then ground heat flux, sensible heat flux and late heat flux. We discuss. Very simple. These are all known to you. In your intermediate you must have studied. Just it is a small rebrushing. The first one is thermal conduction. Of course, you know very well. Thermal conduction in a gas varies a lot from in a solid. What is thermal conduction in a gas? In a gas, the thermal conduction is a phenomenon of thermal conduction. It is a phenomenon of thermal conductivity only. It is explained in a gas. The thermal conduction in a gas can be explained like viscosity. In a column of air, the energy varies from layer to layer. In a column of gas or in a column of air, the energy varies from layer to layer. This clearly indicates that the thermal conductivity is due to the transport of energy. While conducting the heat causes an equality of temperature through the whole mass of gas under consideration. This is the phenomena of thermal conduction in a gas. In a gas, the thermal conductivity is explained like viscosity. In a solid, in a different way. The thermal conduction in a solid is measured by stating the thermal conductivity, which in turn is the ratio of the steady state heat flow along a long rod to the temperature gradient along the same rod. Okay? It is a ratio of steady state heat flow along a long rod to the temperature gradient along the same rod. Okay, this varies among different types of solids and usually depends on temperature and purity of the solid under consideration. So, thermal conduction in a gas, it is explained like viscosity. In a solid, okay, by steady state heat flow. Now, what is thermal capacity? It is also known as heat capacity. It is very simple. The quantity of heat in joules necessary to rise the temperature of a cubic centimeter of body or a system through 1 degree Kelvin is known as thermal capacity or heat capacity. Now, thermal diffusivity. Thermal diffusivity. The thermal conductivity divided by the product of density and specific heat capacity of a substance is known as thermal diffusivity. When thermal conductivity is divided by the product of density and specific heat. Now, what is specific heat? Specific heat is the ratio of the quantity of heat required to raise 1 gram of a substance by 1 degree centigrade to that required by 1 gram of water to raise 1 degree centigrade. This is heat, specific heat. Now, there are 3 very interesting things: ground heat flux, sensible heat flux, latent heat flux. In the radiation balance, these 3 are there. The energy, the solar radiant energy used in heating the ground is known as ground heat flux. The solar radiant energy used in heating the air is known as sensible heat flux. The solar radiant energy used in evaporation, transpiration together is known as latent heat flux. Ground heat flux, energy utilized in heating the ground, energy utilized in heating the air, sensible heat, energy utilized in evaporation, transpiration or together is latent heat flux. So, what is thermal conduction in a gas, in a solid we learned? Thermal capacity or heat capacity, thermal diffusivity and specific heat. Ground heat, sensible heat and latent heat. So, of course, there are innumerable basic temperature terminology, but for understanding our basic course, these are simply segregated by me. That would enlighten you. These are very much enough for understanding at the basic level. Now, the second part of today's lecture is results of research on effect of temperature on important crops. In the previous chapter 2, we discussed the results of research on effect of solar radiation on important crops. Same crops, just we try to understand. Same rice, same sugarcane, same groundnut, same cotton. Now, the temperature regime generally influences not only growth but also the growth pattern of crops. For example, if you take rice crop, effects of low air temperature on rice crop include poor germination, slow growth and discoloration of seedlings, stunted vegetative growth characterized by reduced height and tillering, delayed heading, incomplete panicle emergence, prolonged flowering period because of irregular heading, degeneration of spikelets, finally irregular maturity. These are the effects of low air temperature on rice crop, effects of high temperature. Now, the effects of high temperature in reproductive ways, white spikelets, white panicles, and reduced spikelet sterility you will find. Anthesis stage, it causes high temperature, causes sterility. At the ripening phase, it causes a reduced grain filling. So, on rice crop, low air temperature and high air temperature both cause negative impacts. As far as groundnut is concerned, temperature is the dominant factor that controls the rate of growth in groundnut. Usually, the maximum temperature when it exceeds 54 degrees centigrade, the embryos are killed in groundnut. The rate of peg initiation has been found to be increased at the temperature increasing from 20 to 23 degrees centigrade. However, the peg initiation is highest and the pod growth is also observed to be highest when the temperature range in the soil is around 30 or 30 to 34. So, the peg initiation, it is good at 20 to 23 degrees centigrade, pod growth 30 to 34 degrees centigrade. As far as sugarcane crop is concerned, during the ripening period, frequent fluctuations in temperature adversely affect the sucrose content, minimum 5 degrees centigrade more or less. The cane quality is also affected. In cotton, the temperature effects are more pronounced through delayed germination. Okay, the cotton is basically a tropical plant. The temperature has a decisive effect on beginning germination, while 18 to 30 degrees centigrade is considered optimum for germination. Germination is seriously delayed at soil temperatures below 18. Below 14 degrees centigrade, cotton seeds does not germinate at all normally. So, these are the effects of temperature on rice, groundnut, sugarcane and cotton. Now, in air temperature, one of the important things is the growing degree concept. The growing degree is also known as heat units or thermal units or effective heat units or the growth units. Innumerable names are there. On growing degrees, I developed so many research findings I have done. It's very interesting to me. A degree calculator, growing degree calculator was developed by me for the first time in the world. Of course, this much is the affection I have on growing degree concept. Growing degree is also known as heat units, thermal units, effective heat units or growth units. Okay, what is it? In just 1 minute, in a basic class, you don't need much about it, but I just would like to enlighten you in 1 minute. This is a small and simple concept relating plant growth, development and maturity to the air temperature. I repeat it. This is a small and simple concept of relating plant growth, development and maturity to air temperature. The growth of plants is dependent on the total amount of heat to which it is subjected during its lifetime, that is growth, development and maturity. The formula for growing degree days is G.D.D. Growing degree is equal to T maximum plus T minimum by 2 minus TB. T max, maximum air temperature of the day. T min, minimum temperature of the day. TB, base temperature of the crop. The base temperature by definition, the temperature below which no plant physiological activity takes place. The base temperature in my research I found was 10 degrees centigrade for Kharif season crops, 5 degrees centigrade for tropical, of course, for winter season crops. Okay, 10 degrees centigrade for Kharif, 5 degrees centigrade for Rabi. This is my finding of research. Once again, I would like to say the growing degree day is a very simple concept relating plant growth, development and maturity to air temperature. The final simple point for discussion is units of measurement of temperature. Centigrade, Fahrenheit, Kelvin. Okay, so these are the units of measurement of temperature. The relationship between degree centigrade and degrees Fahrenheit is degree centigrade is equal to 5 by 9 Fahrenheit degrees minus 32. 5 by 9 into degrees Fahrenheit minus 32. Degrees Fahrenheit is equal to 32 plus 9 by 5 degrees centigrade. Okay. So this is how the relation between degree centigrade and degrees Fahrenheit is explained. Degree centigrade is equal to 5 by 9 into degrees Fahrenheit minus 32. Degrees Fahrenheit is equal to 32 plus 9 by 5 degrees centigrade. Thanking you very much for your extraordinary patience in understanding both air temperature and soil temperature. Thanking you very much. May God bless you.